what's the difference between the use tear and active one, between the one we did use nano and directly copy the list of states issue we created the states file director. Remember that yesterday we did nano and we copy and paste the list of the states.
Oh, okay.
To go back to the yes.
Okay.
Where you did it on the actual in the Segwin window, you mean?
Yeah.
Like that. This one I found when Wendy taught it to me, it was just a little bit easier to do it with the up and the down this way with the tail and out card, things like that. You can do it all the same. Is that your question?
Yes.
So what does the command tail does to a file?
Is that the portion where it gives you all of the values in order to type in?
So the portion at the bottom of the file.
Yes.
Okay, so it's the last 350 lines of the file.
And then you can edit and remove those things and then save them separately.
Instead of scrolling the large file, you extract only the lower portion. Okay. Questions?
Could you go to your last slide, what you're working on? Just like we're doing a little bit, sort of the same idea. Your dyes are adsorbing to the surface of your silica?
Yes.
So I don't know. If you've gotten that far, but do you know like if you can put the two together? Have you figured out how to absorb it or how to optimize where that surface location on the silica is going to be?
I have not learned how to do
Yeah.
that quite yet, so it's a future project.
Yeah.
By the end of the week. So I'm sure that Dr. Keelan or Wendy will probably teach me how to do that.
Hope so.
See?
You'll do. Well, basically, answering your question, the technology, what you do. If you have files with part A and part B, and you want to merge them together, you need to make sure that they will not occupy the same space. So when you prepare two files, you need to offset one molecule above another one. And then you just fuse two files together in the same way as you prepare podcards. CAT, file 1 into what you need.
Okay.
Merge them together. Make sense?
Yeah.
We should work on that
We'll do
together.
that today.
Okay.
More questions? I do have a question to your model.
Okay.
Did you count if it is a stoichiometric silica swab? Is it exactly N silicon and 2N oxygens, or it is deviating from this?
I'm not sure. Can you do that on the computer, or how do you
Yes.
check that?
Yes.
I'm not quite sure.
Is the question clear for everyone?
No.
Okay. Is it not clear only for Kelly? Or someone can give sign that wants to know the answer? Okay, no one else is interested. If you have a model and you do have converted into a postcard, on the top line you have a list of elements involved. And on the line number 8, you have a chemical composition, number of ions of each type.
Okay.
If you have only silicon dioxide, then you would have O and Si. And then in the lower bottom, you would have like 100 and 200, if it is a stoichiometric. But if it is not, you may have like 100 silicons and 300 oxygens, which will be chemically strange. Do you check it? Okay.
I have a question. So I know very little about silica. Do you know how many different solid phases of silica there are?
I'm not quite sure. Depending, like we've synthesized ones that have different properties and things like that in our lab because we made 4 different ones. So I don't know how many exactly there are. You can synthesize in a different way to have kind of a little bit different properties, but they're going to have a similar structure. I'm right? Maybe
Yes,
you want to
yes.
add. Okay.
There are several, almost a dozen.
Do you use any NCM class?
I have not in my research, but we do in our group.
Okay.
We use MSTEM48.
I tried making something else.
Alan makes those
Okay.
a lot.
Okay. How would you formulate your scientific question to what you would like to learn from your model?
I would like to learn how the REU2015 or the different types of dyes bind onto the silica and how they're different based on their different charges and things like that.
Do you anticipate the molecule will be decomposed when it touches the surface, or not?
No, I'm
Just
not sure though.
just bound.
Just bound.
So you need binding energy.
Yes.
Okay, very good. Last chance? No? Let's thank Kaitlyn once again. So we are